This is 2015 number 3. Notice that we are in the non-calculator section now, so we still have about 15 minutes on average to solve each one of these problems, but now we're not allowed to use calculators, so we have to do everything by hand. So sometimes we'll give you a table of values. So let's kind of see what these tables are. We're going to circle the variables and box the units. So t is a variable and it's measured in minutes. V of t is a variable and measured in meters per minute. So notice that this is a first derivative, all right? Because meters per minute is a derivative. It says Joanna jogs along a straight path for 0 less than t less than 40, less than or equal to 40. Joanna's velocity is given by this differentiable function v. So this is the velocity of her travel. Selected values of v of t, where t is measured in minutes and v of t is measured in meters per minute, and you guys can make these markings on your paper as well, are given in the table above. Part A. Use the data in the table to estimate the value of v prime of 16. So this is a big part. They love to ask this question on the AP exam, all right? And it has nothing to do with calculus, actually, to be surprised. Estimate, all right? When you see that word estimate, that means that you are not able to actually figure out the value of v prime of 16 because we don't have an equation. We can't find the derivative if we don't have an equation. So we're going to estimate the value of v prime of 16. So if I can draw you a little graph, I mean, I won't actually plot these points, but let's just pretend that we had a little graph that looked like this. If I wanted to know v prime of 16, let's say this was 16 right here, all right? If I wanted to know v prime of 16, that's the slope of a tangent line. So let's say that I drew a tangent line and I wanted to approximate that tangent line. A good way of approximating or estimating the slope of a tangent line is by using the slope of a secant line. So finding an average slope or the average rate of change in order to estimate the instantaneous rate of change. So to estimate the value of v prime of 16, we need to find the average rate of change around 16. So here's what they're looking for. They're looking for you to see up here, and which of these numbers is are the best numbers to use to find an average rate of change, and that would be 12 and 20, because 16 falls right in between 12 and 20. So what we're going to do is, to find an estimate of v prime of 16, we're going to say that that's about equal to the average rate of change, or the average slope between those 2 points. So that would be v of 20 minus v of 12 over 20 minus 12. So you have to show your work. You don't necessarily need to write this down. You could have plugged in v of 20 already and plugged in v of 12, but I just wanted to show you where I'm getting those. So v of 20 is 240. V of 12 is 200. And then we have 20 minus 12 on the bottom. So that's 40 over 8, which is equal to 5. All right, now you have to be careful. They love to on these problems because these problems are not very difficult, so they love to mark off points if you do not include units. So make sure to include the units on this problem. 5, and then the units for velocity were meters per minute. So the derivative of that, v prime, would be meters per minute, or meters per minute squared. And that is the answer for part A. So whenever you're asked to estimate, you will not be able to figure out an exact amount. You will always have to approximate what it is. So that's worth 1 point on the AP exam. If we look at part B, you'll notice there's this crazy integral symbol. You guys don't know how to do that yet with right, Riemann sum, so we'll skip over that part. Part C says Bob is riding his bicycle along the same path that Joanna is on for 0 less than t less than 10. Bob's velocity is given by, or modeled by, this function. All right, so that's the function that models his velocity, where t is measured in minutes, t is measured in minutes, and b of t is measured in meters per minute. It says find Bob's acceleration. Well, how is acceleration related to velocity? If this is his velocity, it's the derivative of the velocity. So we want to find Bob's acceleration at t equals 5. Just means find the derivative and plug in 5. So for part C, if Bob's velocity is t cubed minus 6t squared plus 300, then his derivative, or the acceleration of that, would be 3t squared minus 12t. And I want to know what is his velocity at 5 seconds, or 5 minutes, I should say. So I plug in 5, so I get 3 times 5 squared minus 12 times 5. That's 3 times 25 is 75, minus 12 times 5 is 60. So that's 15. And again, please do not forget about the units. So acceleration, let's see what units acceleration are measured in. If Bob's velocity is measured in meters per minute, and we take the derivative of that, that's going to be meters per minute, or meters per minute squared. Meters per minute squared. Bring that down a little bit. And that is worth 2 points on the AP exam. And part D says find the average velocity, and we are going to wait for that until second semester as well. So this is the only part you know how to do for number 3.